Welcome students to another video lecture with Mr. Kennett. So we are combining two lessons here, 9.3 as well as 9.4. So what we're trying to do today is connect something we learned back in chapter 5. If you recall, we learned about something called the constant of proportionality. And today we're going to learn that constant of proportionality we learned about can have a better name in algebra called slope. Much simpler as well. So how do we find the slope? The constant rate of change, aka and the slope. So go ahead and pause here and copy down what you see. Please make sure this is large enough to read. We're going to read this formula a lot. So go ahead and pause here and copy down what you see. Okay, welcome back, students. So what we're learning about is the constant rate of change and slope today. You're going to hear me reference this slope a lot, okay? So the constant rate of change in a linear relationship is called the, yep, you're right, it's the slope. And just like in our constant of proportionality, that was when we had the equation y equals kx there. And remember, we called this k the constant of proportionality. And again, today we're going to learn there's a way easier name for it. And this is when the line does not go through the origin, and we only use y equals kx when it went through the origin because they were proportional. Now we're going to learn about something that can work even when it doesn't go through the origin. And again, this k we learned about, we're going to learn a new name for it. We're going to call it slope. And as you can see, we're going to use the letter m for slope. And go ahead and copy down what you see over there. Well, actually, I've already asked that. So now we're going to look at these change in dependent variable on the top with the change in the independent variable on the bottom. And why we put that y on the top there is when we solve for k here. Remember, we had to use the multiplicative inverse, aka divide by x, which means k equals y over x. The dependent is on the top, and the independent, the x, is on the bottom. This formula looks a little complex with its subscripts, those little 2's and little 1's. Remember, those are little and below. They're not a part of our formula. They're going to tell us how to place our ordered pairs there. So let's jump into a problem and see how we do this. So go ahead and pause here and copy down this problem. And it's going to be really important that you copy it down with these ordered pairs noticeably going through the corners. So please use graph paper if you don't have graph paper on your Cornell note. Go grab some. It's important that this is very clear. Go ahead and pause here and copy down what you see. Okay, welcome back. So we're about to find the slope of this line, and we're actually going to do it visually right now. We're going to look at it, try and figure out two ordered pairs so we can find or substitute them into the formula. So we're on step one here. We're finding two different ordered pairs. And the way you're going to figure out it's a good ordered pair to choose is you're looking for spots where this line goes through the corner of a square on your graph paper. So this would be a good ordered pair to use, as well as this one. If the line goes through like this on your graph paper, we can't know if that's a whole number or not, so it's more difficult to use in the formula. So again, good ordered pairs are identified by looking for where the line would go through the corner. Can you start finding some of those on our line on this problem? Awesome. So I had one marked already. This one right on the y-axis is going to be great. So that ordered pair I marked there is 0, -2. And now you're going to notice there's a bunch of ordered pairs that go through the corners. And it's actually okay to use any one of those for the problem. So just to make it simple, I'm going to use this one right here. And that ordered pair is -1, 1. So we have two ordered pairs. And notice this formula has a x and a y show up twice. And that's where the subscript matters. We can call this first ordered pair x1 and y1. And this second ordered pair we're going to call x2 comma y2. It's really important you realize it doesn't matter which one we call the first one and which one we call the second. What's going to matter is that when we substitute these ordered pairs in the formula, we have to make sure that these ordered pairs stay on top of each other. Okay, so let's see how this formula works. Oh, what was that formula again we're going to have to write down? Because whenever we use a formula, we should write the formula down. That's how we memorize it. So, oh, there it is. Read that one more time and go ahead and copy that into our problem. M equals y2 minus y1. The change in the y value is on the top, over x2 minus x1. The change in the x value is always on the bottom. And now we've already called one of these the first and one of these the second. Again, it doesn't matter which one's which. It matters that they are on top of each other when we substitute them into the formula. So the m is what we're solving for. What does m stand for? Yeah, you're right, it's slope. Okay, now we're substituting into the formula. This is y1 over here. Okay, so I'm going to put y1 first. See, I've already switched it up. And this is y2, and we're just going to minus the other one. And again, it doesn't matter that I switch the order. What's going to matter is that our ordered pairs are on top of each other. They are in a vertical column. So if I put -2 on top, the x value I have to put below it is the one that's in its ordered pair. And that's 0. Notice the ordered pair is in a vertical column on top of each other. We have a minus sign. And since I have 1 on the top here, I have to use this x value right below it. And I'm going to use parentheses. In fact, I probably should use parentheses on every substitution, because that's going to help us see that in this line of our formula, we have a negative and a negative together. Oh, that's not good. So we're bringing that straight down. M equals -2 minus 1. So we're just following the order of operations. -2 minus 1 is -3. 0 minus -1. Remember, that just means 0 plus 1 is 1. Oh, and -3 divided by 1 equals -3. The slope of this blue line in our problem is -3. So that's the answer, and I like to write that out in words so we totally understand what we're doing. The slope of the line was, it's not was, it still is, -3. And that's how we're going to use the slope formula. We're going to substitute 2 different ordered pairs into the formula, and then we're just going to follow the order of operations as we go down and solve. It's going to be really common that we get a fractional answer in these problems. We're going to have a couple more examples to copy down, and then we're going to have a visual clue of how to figure out something is a positive slope or something is a negative slope. So this ended up being a negative slope. And notice, it kind of slopes down when we read it from left to right. So let's go ahead and skip ahead here. We have 2 problems that we're going to do in class together. So pause here and copy down what you see. Okay, welcome back. If you did not leave space below example 1 for us to do example 1, please erase it and make some space. Now we're going to jump ahead to the visual clue part of the lesson. And these lines that you're drawing on the coordinate plane do not have to be exact. Just make sure they look like what I drew. As long as they look like what I drew, we can use them for our visual clues about the slope of a line. So this is how we're going to logically understand if something should have been a positive slope or something should have been a negative slope, and we ended up doing some order of operations incorrect. So go ahead and pause here and copy down these 2 visuals. Awesome, welcome back. We have 2 more visuals we're going to want to copy down. We're going to have the chance that there's a 0 slope. Notice it's a flat line from left to right. It doesn't go up or down at all. And that's what slope is. It's how much something goes up or down? And then we have the funny answer, an undefined slope. And that's because it's impossible to climb a vertical wall. And we're going to see why mathematically this happens, that we get an undefined slope. Well, that's our lesson. So go ahead and make sure you've copied down these visuals. Pause if you need to. And again, if you have any questions at all, please copy them down in the question column because that helps us study and ask things in class. I'll see you soon.